Now we will be going into terms that we will need to go in much more deeper in the future. And one of the most important concepts in AI development is the proper splitting of data for training, for validation, and for testing. Now, this might seem like a technical detail, but it has profound implications for how you can trust an AI system in your clinical practice. A standard approach is to split your data into three parts: 70% for training initial, then 20% for validation, and then 10% for testing. But understanding what happens in each phase is crucial. Now, the training data is used to teach the model patterns and relationships. This is like medical school. The model learns from examples and develops its understanding on how different factors relate to outcomes. This is just medical school you are learning through books, largely. Now, then is the validation data, and this is used during the model development process to tune parameters and prevent overfitting, meaning that it just does not only predict one basic thing, right? This is like a residency evaluation, right? You are already a resident. You are done from medical school. Now you are a training doctor, right? You're testing the model's performance and adjusting its its training based on how it actually does. So, as we see in regular healthcare, hardly any patient reads like a textbook. Few patients read like a textbook. There are patients that read like a textbook, but few of them read like a textbook. And this is the validation stage. The validation will see if this model can actually deal with slightly different scenarios from your training data. Now, then we get to testing data. And this is used only once at the very end to evaluate the final model's performance. This is like your board exams or your live patient exams. Back in the day, we actually used to have live exams where the professor is monitoring us, seeing what we're doing, and that was a live exam. So this is the final assessment of whether the model is ready for real-world use. Of course, after launch, there will still be changes needed. And of course, that will be a different topic. We will talk about that. Here's why all of this matters. If you use the same data for training and testing, you are essentially giving the model the answers to the test before it actually takes it, right? So the model might memorize specific cases rather than learning generalized patterns. In clinical terms, this is like a resident who memorized UWorld questions for the USMLE but fails when faced with real patients. Or the resident who might do well on a practice test but cannot really apply their knowledge in real-world situations. And if, let's say, for example, a resident only goes by the book, if the patient presents like the book, it says chest pain, left-sided, pressure, elephant sitting on your chest, and the resident thinks that that is the only presentation of chest pain and MI, myocardial infarction, then that resident will not do well in real life. This is called overfitting. This is one of the biggest risks in healthcare. And a model that's overfitting to its training data might perform brilliantly on the specific patients it was trained on, but fail like enormously when deployed on a different hospital or a different set of patient populations. So when you are evaluating AI tools, ask about how they were validated. Was the testing done on completely separate data? Was it tested on different hospitals or with different patient populations? How does the performance change when the model encounters patients who are different from those from which it was trained on? Dear all, I hope you are doing great and that you are liking these lessons and you are enjoying and you are learning. And I did want to suggest something as an option for you. Only if you are one of those who want to have this content in a more organized manner, there is a program that I have set up that you can find in the description. It absolutely is not necessary. However, it is only for those who do thrive in an organized approach, and there just might be a few more goodies there as well. Anyways, I wanted to share this, and now back to the video. Now, to recap, training versus testing your model. Properly splitting your data is crucial for reliable healthcare. Now, training data, usually 70%. The validation data, usually 20%. Testing data, usually 10%. Now, train is like medical school, validation is like residency, and testing is the board exam or the practical exams that I had to go through. They're not here. They're not actually done these days, at least in the US. But that's it. Now, this is a little bit on the side notes. Now, these three charts show you different approaches to splitting your healthcare data for AI development, and understanding these differences is crucial for evaluating AI tools. So you need to ask the vendor, hey, what was your training data set? Now, let's say for the first chart right over here, it shows the most conservative approach: 80% training data and only 10% for the validation and test data. Now, this approach minimizes the data available for learning, but provides limited data for validation testing. Now, in the middle, the second one, this represents a more of a standard approach where we have 70% training data, 15% validation, and 15% testing. Now, this is often considered the gold standard because it provides enough data for robust validation during development, while still reserving sufficient data for final testing. Now, the third one shows a much more of an aggressive validation approach. Now, 60% training data, 20% validation, and 20% testing. Now, this approach is used when you're particularly concerned about overfitting, or when you are developing models that will be deployed across different patient populations. So all of these things matter. So this matters for you as a healthcare professional, because when a vendor comes in, you have to ask them these questions, because you are the physician in the loop. You are not replaced by AI. You are the person who is working with AI. If they use the first approach, meaning minimal testing data, be cautious. The model might not generalize well to your patient population. If they use the standard approach, the 70-15 and the 15 split, that's reassuring for most applications. If they used the more conservative approach, 60-20-20 split, that suggests that they were being extra careful about validation, which is good for high stakes clinical applications. So again, you know your clinical environment and you know your situation. Remember our medical school analogy. You want an AI system that didn't just memorize the textbook, meaning the training data, but was also thoroughly tested on multiple residency evaluations at the validation stage, and passed rigorous board exams and live testing before being trusted with patient care. Now, the key question to ask vendors is, what percentage of your data was held back for final testing? And was the testing done in patients similar to the type of patients that we have here in my facility, in my health network, in my town, in my country, in my universe?